Good morning everybody. Today we will start new chapter. It is polynomials and it is the second chapter of class 9th class. It's so simple. Already in class 9 you have studied the chapter polynomials and it is little bit different from that one. So first of all I'm explaining about the polynomials. When the algebraic terms are connected with plus or minus sign, then algebraic expressions are formed. And although the algebraic expressions where the power of the variables be a whole number or non-negative integers, they are known as polynomials. We will classify the polynomials according to the terms and according to the degree. According to the terms, we classify polynomials in several groups: monomials having one term, binomials having two terms, trinomials having three terms, quadrinomials having four terms, and later on it will be known as polynomials if it is having more than four terms. Like this, according to degree, if a polynomial be of degree 1, then it is known as linear polynomial. Linear polynomial, I am giving one example: px equals 2x plus 1. It may be monomial or binomial. Next one is quadratic polynomial. It is a polynomial of degree 2. It may be monomial, binomial or trinomial. I am giving examples: px equals, you are taking x square plus x plus 1. You may take px equals x square minus 9. These are the examples of degree 2 polynomials, that is quadratic. In cubic polynomial, a polynomial of degree 3 is known as cubic polynomial. Here you may take examples: px equals x to the power 3 minus 8. By quadratic polynomials, a polynomial of degree 4 is called biquadratic polynomial. Example is px equals x to the power 4 plus 16, and later on it is known as polynomial simple. Where the question of the degree, already in class 9 you have studied that in a polynomial a term where the exponent of the variable maximum, that is known as the degree of that polynomial. Next is constant polynomial. A polynomial whose degree is 0, that is called constant polynomial. Example, you may take px equals 2, it is a constant polynomial. Next one is the 0 of a polynomial. If alpha be any real number, then for any polynomial px, on substituting x equals alpha, if p alpha is 0, then alpha is called the 0 of that polynomial. I am giving example: if px equals x to the power 3 minus 8, and on substituting x equals to p2 will be 0, so 2 is known as the 0 of the polynomial, since it is reducing the value into 0. But now here we have to see one thing more, that if we are drawing the graphs of the polynomials, then we will check that whether it is either touching the x-axis or intersecting the x-axis or not. If it is either touching or intersecting the x-axis, then abscissa of that point is also known as the 0 of that polynomial. And we will study this here under the headings of geometrical meaning of the zeros of a polynomial. There is one very important term, zero polynomial. And what is the difference between zeros of the polynomial? If px equals 0, then it is called zero polynomials, degree not defined. And zeros of a polynomials are those real values which changes numerically into 0.